I am B. Rajeshwari. I am currently pursuing third year B.Tech Department of Electronic Communication Engineering at NRI Institute of Technology, Agirpalli. Today I am here to present Embedded System Internship Project Washing Machine Simulator using PIC16F877A Microcontroller. Objectives are develop a washing machine interface that enables users to interact with various washing modes by pressing digital keypads and adjust water levels through long presses. Implement a system to display the ongoing function, remaining time, and ensure the machine holds operation upon detecting lid opening, thereby enhancing user safety and convenience. Overview of this presentation. Introduction. EMERTXE PIC16F877A Peripherals, Software tools used, Functional requirement, Conclusion. Introduction of this presentation. Embedded systems are specialized computing systems that are designed to perform specific tasks or functions within a larger system. Unlike general purpose computers, which are designed to run a variety of applications, embedded systems are typically built to perform a dedicated function or set of functions. They are often found in everyday devices such as smartphones, digital cameras, household appliances, and automotive systems. Embedded systems consist of hardware components such as microcontrollers or microprocessors, memory devices, and input-output interfaces, all of which are designed to work together to execute the embedded software. The software, also known as firmware, is typically developed to meet the specific requirements of the embedded system and is often optimized for performance, power consumption, and size. One of the key characteristics of embedded system is their real-time operation, meaning they must respond to inputs and events within a specified time frame. This requirement is critical in applications where timing is crucial, such as in automotive systems, industrial control systems, and medical devices. A washing machine is a common household appliance that automates the process of cleaning clothes. It typically consists of various components, including a drum for holding clothes, a motor for agitating the clothes, pumps for water circulation, sensors for detecting water levels and temperatures, and a control system for managing the washing process. The control system in a washing machine is an example of an embedded system, as it is responsible for executing tasks such as selecting washing cycles, adjusting water levels and temperature, and monitoring the operation of the machine. Embedded systems plays a crucial role in enhancing the functionality, efficiency, and user experience of washing machines and other household appliances. Overall, embedded systems play a crucial role in modern technology, enabling the functionality of a wide range of devices and systems that we rely on in our daily lives. Types of embedded systems. There are two types of embedded systems based on performance and functional requirements based on the performance of the microcontroller. In based on performance and functional requirements, there are four types: real-time, standalone, network, mobile. In based on the performance of the microcontroller, there are three types: small scale, medium scale, sophisticated. Components of embedded systems. Input are given at sensors, A to D converters. We are processing at central processing unit, D to A converters. Output is taken as actuators. Software is written from CPU or to CPU memory. FPGA field programmable gate array. ASIC application specific integrated circuit. User interface. Diagnostic port. Electromechanical backup and safety, external environment. What is embedded C? Embedded C is a variant of the C programming language that is specifically designed for programming embedded systems. It includes features that make it well suited for embedded applications such as direct access to hardware peripherals, fixed width data types, and limited or no standard library support. In embedded C, developers often interact directly with hardware registers and memory to control the behavior of the embedded system. This low-level programming approach allows for precise control over the hardware and can result in more efficient code execution. Embedded C programming requires an understanding of the target hardware architecture and specific knowledge of the microcontroller or microprocessor being used. It is widely used in a variety of embedded applications, including consumer electronics, automotive systems, industrial automation, and more. Differences between C programming and embedded C programming. C programming means possesses native development in nature. Embedded C possesses cross development in nature, independent of hardware architecture. Embedded C dependent on hardware architecture, microcontroller or other device. C programming used for desktop applications, OS and PC memories. Used for limited sources like RAM, ROM and input-output peripherals on embedded controllers. Data types in C. There are primarily three data types in C. Primary data type, user-defined data type, derived data type. In primary data type, char, float, int, void. In char, signed, assigned, float, double, long, double. Int, long int, unsigned long int, long int, unsigned long int, short int, unsigned short int. User defined data types, enum, type def. Derived data type, pointers, arrays, structures, unions. Data types in C are used to define the type of data that a variable can hold. They are important because they determine the size and layout of the variable's memory, which affects how the data is interpreted and manipulated by the program. Operators in C. There are so many operators in C programming language: arithmetic operators, logical operators, bitwise operator, conditional operator, assignment operators, relational operators, MIC operators. Arithmetic operators means it performs arithmetic operations. Logical operators means it performs AND OR logics. Gates logics it performs. Relational operator means equal to, greater than, less than, and so on. Assignment operators means percentage, and so on. Conditional statements in C. If else statements, if else, if nested if, switch. There are a loop conditions. If condition is true, then it will close the whole system. If there is a false, then it will goes to else statement. After that else statement, loop will be closed. Similar to nested if and switch case statements. Microcontroller PIC16F877A. In this internship project, we used PIC16F877A microcontroller. Bus width is 8 bits. Pin count, it has total number of 40 pin IC, and there are 33 pins for input and output. Program memory are used at 14.3 kilobytes. CPU used at 5 million instructions per second. RAM size used at 368 bytes. EEPROM size 256 bytes. Interfaces. LED means light emitting diodes are semiconductor devices that emit light when an electric current passes through them. The semiconductor chip is typically made of gallium arsenide, gallium phosphide, gallium nitride, which determines the color of the emitted light. CLCD. CLCD stands for character LCD, which refers to the type of liquid crystal display that is commonly used to display characters and symbols. To use a character LCD, you typically need to connect it to a microcontroller or other device using a communication protocol such as 12C, I2C or SPI. These two are protocols: serial peripheral protocol or intercommunication protocol. Character LCDs are popular in various applications such as electronic devices, appliances, and industrial equipment due to their low cost, simplicity, and readability. Tactile switch. This is one type of used for washing machine project. Tactile switch, also known as tactile button or tactile dome switch, is a type of momentary push down switch. These switches are commonly used in electronics and electrical devices where a user interface is required, such as keyboards, keypads, and control panels. Fan. A fan is a key component of many electronic devices and systems designed to provide active cooling by moving air. Fans are typically small, lightweight, and power efficient, making them ideal for integration into devices where space and energy consumption are critical consideration. These fans are commonly used in various applications including computers, servers, automotive electronics, and industrial equipments. The fan's speed and operations are often controlled by a microcontroller. Buzzer. Buzzer has two pins. One is VCC and ground. Buzzer are small electromechanical components that are designed to convert electrical signals into sound waves. Typically, buzzers consist of a coil and a diaphragm which vibrates to produce sound when an alternating current is applied. There is a two connections include. Positive connection is included for VCC and there is a negative connection represented as ground. When connected to a microcontroller or other control circuit, the buzzer can be activated by applying a digital output high to the positive pin while keeping the negative pin connected to ground. Timer. Microcontroller has three independent timers: timer 0, timer 1, timer 2. Timer 0 is an 8-bit timer with an 8-bit prescaler. It can be used for basic timing functions and is often used for generating interrupts at regular intervals. Timer 1 is a versatile 16-bit timer with a prescaler and postscaler. It can be used for more precise timing functions such as generating PWM signals, measuring time intervals, and implementing real-time clock functions. Timer 2 is an 8-bit timer with a prescaler and postscaler. It is often used for generating fixed frequency PWM signals and for timing applications that require higher resolution than timer 0. Software tools used. MPLAB XDE is an integrated development created by Microchip Technology for developing applications for microchip microcontrollers and digital signal controllers. DSCS. It is a powerful tool that provides a comprehensive development environment for embedded system developers. Some key features: code editor, project management, debugger, simulator, device support, plugin support. PIC16F877A is a software simulation tool for PIC microcontrollers developed by Netronic Soft. It allows developers to simulate and debug PIC microcontrollers programs without the need for actual hardware. PIC16F877A provides a virtual environment where users can write, test, and debug their PIC assembly or C language code. Some key features: simulation environment, code editor, debugger, peripheral simulation, virtual oscilloscope, Support for different PIC models. XC compiler is a compiler for the microchip PIC microcontroller family. It has some features: C standard compliance, optimization, peripheral libraries, integration with MPLAB IDE, support for different PIC families. Functional requirement. In middle there is a microcontroller, power on switch 5, pause or stop switch 6, navigation switch 4, door status switch 1, display washing status, buzzer, motor. These are all functional requirement for to implement the washing machine. Power on screen description. Press key 5 on power on washing machine on the CLCD. Wait till SW5 is pressed. If SW5 is pressed, print power on washing machine. Washing program screen description. The washing program menu will contain the following washing options: daily, heavy, delicates, whites, stain wash, eco, cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua store, and so on. A long press of SW4 will select the option highlighted with star. Water level screen description. The screen should allow the user to select water level. The water level menu will contain the following displays: auto, low, medium, high, low using the keypad switch 4. We can scroll between the options available. A long press of switch 4 will select the option highlighted with start screen description. If switch 5 is pressed, start the mission, display the function selected and time taken. Then switch to function screen. Function screen description. Once mission started, display the function ongoing. It can be wash, rinse or spin, along with display the time left on the CLCD. Description. Process. Display the function and time left. Output. Display the function and the time left function wash, rinse, spin, time based on washing program and water level. Set time. If switch 5 is pressed, start the washing machine. If switch 6 is pressed, pass the washing machine function. Wash time 00:50 switch 5. Start switch 6. Pause. The status of switch 1 is indicative of the door status. When the switch is pressed, it signifies that the door is open. Conversely, when the switch is not pressed, it indicates that the door is closed. If switch 1 is pressed, turn on the buzzer and display door open, please close. Complete status screen description. Once all programs are completed, display notifications. Program completed, remove cloths on the CLCD. Output print program completed, remove cloths. Going to the PIC16F877A software. Once you installed PIC16F877A software in your systems, go to the select the clock frequency in megahertz and give LCD code. Code will be print onto the PIC16F877A microcontroller. After PIC16F877A microcontroller, select the switches what do you want to press. After washing machine will be programmed, you will click on switch numbers and it will indicate rinse or bed sheets, woolens or dry or spin. It will indicate. After washing program, only, wash only, read alone, daily, and after indicating washing machine rinse or drying or that cloths removing, water levels are indicating. It will water level as a low or medium or high. It will depends on cloths. After giving a function water level, it starts some specific time. In that time the clothes are washing by controlling the fan. After completed that time, wait some time. After completing that time, it will completed washing. Remove clothes, it will indicates the buzzer. So these are steps for PIC16F877A software that are used in a washing machine project. So this is a virtual lab washing machine project on a software. I have really experienced about virtual labs on this EMERTXE internship project. Conclusion. In conclusion, the washing machine simulator project successfully achieved its goal of developing an interactive interface for a washing machine using the PIC16F877A Microcontroller. The project allows users to select various washing modes and water levels. There are so many different washing modes like rinse, drying, spin. It will indicate the washing modes, and water levels. Some are low, medium, high, with the interface displaying at display at the CLCD display. The current function and remaining time also display on CLCD only. This project demonstrates the application of embedded systems in creating user-friendly interfaces for everyday appliances, showcasing the versatility and practicality of microcontroller based systems in real-world scenarios. Thank you for this presentation.